The planet Mercury is not what you think. Almost everyone is wrong about Mercury because almost everything you were taught in school about this planet is wrong. While you may have heard that the closest planet to the sun has only ever been an overcooked, lifeless rock, it turns out that Mercury is a more Earth-like planet than we ever thought possible. This is a strange world with a complicated past and a deeper mystery hidden in the shadows that needs to be solved, because ultimately, this could be a window into the fate of our own planet. The problem with Mercury is that even though it's located relatively close to the Earth, it's also extremely difficult to reach. So even by the time we had walked on the Moon, landed probes on Venus, and drove cars on Mars, Mercury remained one of the solar system's least understood planets. And this is nothing new, because for most of human history, learning anything about it has been nearly impossible. Not only is Mercury small, smaller than some moons, but the real problem is that when you try to observe it from Earth, you are always looking in the direction of the sun, and Mercury orbits it so closely that most of the time the planet only appears as a silhouette. It's like any picture with a strong backlight. You can only see the subject's basic shape, and the fact that Mercury is round isn't exactly a surprise. Mercury is very close to us. Most of the time, it's actually Earth's closest neighbor, not Venus or Mars. So in theory, launching a spacecraft to study it should be relatively easy. But it's not, and there are two very good reasons for that. First, we have to consider that Mercury is named after the fastest of the Roman gods, and there's a good reason for this. It's the fastest moving planet in our solar system, orbiting the sun once every 88 days. So in the time it takes the Earth to travel around the sun one time, Mercury can do 4 round trips of its own. This means a spacecraft from Earth would have to pick up an enormous amount of speed to just reach it, and that's where the hard part begins. If we were talking about any other planet, the approach would be relatively simple, but since Mercury is so close to the sun, you have to account for the immense gravity of this gigantic object. If you don't position the spacecraft with absolute precision, you could accidentally fling it into the sun. Plus, anything you send would have to be built to withstand the brutal heat when it arrives. So when NASA launched the first mission to explore Mercury in 1973 with a probe called Mariner 10, its journey was far from easy. Before reaching its destination, Mariner would fly past Venus, and it did this in order to use the planet's gravity as a slingshot to redirect itself down toward Mercury. It was the first mission to pull off this kind of gravity assist maneuver, and the first to visit 2 planets in the same flight. All of this allowed Mariner 10 to fly past Mercury 3 separate times. However, Mariner was never designed to stay in Mercury's orbit. That is a problem that would take NASA another 20 years to solve. But during its short flyby windows, Mariner 10 was able to deliver the first clear view of our mysterious neighbor planet. And what it found was not what NASA was expecting. As the spacecraft approached Mercury, the planet initially looked a lot like our own moon. Its surface was pale gray and covered by marks from asteroid impacts. One enormous structure that became one of Mercury's defining landmarks is the Caloris Basin, an impact crater larger than the state of Texas. But as it got closer, things started to get weirder. Mercury orbits the sun every 88 Earth days, and it rotates once every 59 days. So 3 rotations for every 2 orbits, which creates a strange pattern. Since both of these motions happen counterclockwise, a single Mercurian day from sunup to sunset and sunrise again actually lasts 2 full Mercurian years. And this means that any given location on the surface endures a year of scorching heat followed by a year of freezing darkness. As it spins, it's extremely hot on one side and extremely cold on the other, reaching temperatures as low as negative 173 degrees Celsius and as high as 427 degrees. One of Mariner 10's most important geological discoveries was the presence of incredibly steep and long cliffs that looked unlike anything seen on the moon. Some were nearly 3 kilometers high and stretched for hundreds of kilometers in length. But the most surprising discovery was that Mercury has a magnetic field just like the Earth. Before Mariner 10, scientists had expected Mercury to be a completely desolate, virtually dead chunk of rock. That would make sense given its proximity to the Sun. But the presence of a magnetic field implied that underneath the surface, the planet still had an active core. This is what we have inside the Earth, and the power of that magnetic field is what protects us from the deadly radiation of the Sun. So you need one of these in order to have life on your planet. We know that on Earth, magnetism is created by super hot liquid metal flowing around a solid iron ball at the planet's core. In their studies of Mars and Venus, NASA did not find a magnetic field, so we assumed that Earth was the only planet left with an actively spinning core, but then Mercury complicated things. And to be able to generate a detectable magnetic field on a planet as small as Mercury, its own core had to be absolutely massive. So this is when a new history of Mercury began taking shape. The planet began forming around 4.6 billion years ago, and the craters on the surface suggested that it had been bombarded by comets and asteroids for hundreds of millions of years. Scientists interpreted the presence of a magnetic field as a sign that Mercury had an unusually large, iron-rich core that formed as the densest magma concentrated at its center. And that discovery, coupled with the giant cliffs on its surface, suggested that as the interior cooled, Mercury might have actually begun shrinking, almost like an apple wrinkling as it dries out. But despite all of these findings, Mariner 10 left us with a lot more questions than answers. As impressive as the mission was for its time, the spacecraft saw the planet under roughly the same lighting conditions on each of its 3 flybys, so it could only image about 45% of the surface. The mission transformed Mercury from a blur into a real world, but it still left more than half the planet unseen, including the polar regions where NASA believed there could be something genuinely mind-blowing hidden beneath the shadows. So, in 1998, 23 years after Mariner 10 shut down, NASA approved a new mission to Mercury, MESSENGER, which stands for Mercury Surface Space Environment Geochemistry and Ranging. Not a perfect acronym, but it works. The goal here was to understand more of Mercury's ancient past, the origin of its magnetic field, and the mystery of its North Pole. MESSENGER launched in August 2004, but its path to Mercury was much more complicated than Mariner's. The journey would take nearly 7 years, and to save as much fuel and gather as much data as possible, the probe would take a complicated route that involved flying once by the Earth, twice by Venus, and 3 times by Mercury before finally positioning itself into orbit around the closest planet to the Sun. And thanks to this complex feat of navigation, NASA was finally able to see Mercury in its entirety. Over the course of 4 years, starting in 2011, MESSENGER was able to completely map out the planet using cameras, collect a massive amount of data from its gamma, X-ray, and neutron spectrometers, and more accurately measure its magnetic field until finally, the mission came to an abrupt and violent end. For starters, MESSENGER revealed that Mercury had once been covered in highly active volcanoes. Its surface is wrapped in expansive smooth plains formed by flowing lava, which made the giant cliffs first seen by Mariner 10 even more important. They told us that Mercury was shrinking even longer and deeper than scientists had realized. By some estimates, Mercury had shrunk by nearly 14 kilometers in diameter since it formed over 4.6 billion years ago. That's 5 times faster than anyone had thought possible. And then there was the magnetic field. Mariner 10 had already proved that Mercury had one, but MESSENGER revealed that it was even stranger than expected. Instead of being neatly centered inside the planet, the entire field was shifted toward the North Pole, almost as if it was tilted and knocked out of place. But what's even more surprising is that since Mercury is so close to the Sun, the field itself was constantly being stretched and twisted by solar winds. All of this suggested that Mercury's interior was still alive in a way no one had fully expected. Using measurements of the planet's gravity, its shape, and rotation, MESSENGER showed that Mercury has an enormous solid iron core in its center and, surprisingly, also a fluid outer core. Together, Mercury's cores make up 57% of the planet's volume compared to Earth's 17%, which explains how such a tiny planet could generate any magnetic field at all. And then, MESSENGER turned its sights onto the North Pole. For years, radar observations from Earth had hinted that something bright and reflective was hiding at Mercury's poles. And what MESSENGER finally confirmed was that these were actually large deposits of frozen water. But how could there be ice so close to the sun? The answer, it turns out, is a lot more simple than you'd expect. Mercury isn't tilted on its axis like other planets, so it spins straight up and down like a top, not tilted like a globe. And as a result, the sun is never able to shine over its polar regions. It only ever hits them from a side angle, meaning many of these deep craters on the top and bottom of the planet will have areas inside them that have remained in permanent shadow for billions of years, making them cold enough to preserve ice. Thanks to MESSENGER, Mercury was no longer the solar system's most simple planet. By the end of the mission, we knew more about it than ever before, but if anything, it had only become more mysterious. For example, we are still trying to figure out what's going on with these strange geological features on Mercury's surface, which we have never seen on any planet before. Scientists are calling them hollows, and the process that creates them is completely unknown. Our best theory so far is that they're formed by evaporation, which would suggest that Mercury was once more alive than we had predicted. And if its surface had water in the ancient past, then Mercury could have started out its life much closer to the Earth than previously imagined. And it was only through some unknown series of events that the planet fell down or was pushed deeper into the orbit of the Sun. And if true, then studying Mercury will actually provide us with a clear window into the apocalyptic future of the Earth. Now, while we almost certainly won't end up falling into the sun, we're still going to end up cooked because as the sun ages, it will actually expand outward over the next billion years until it swallows up Mercury and Venus entirely, and the Earth ends up as the closest planet to the sun, at which point we'll look a lot like Mercury. And speaking of ends, remember how the MESSENGER probe had a violent conclusion? Well, now we have a new space probe on the way to Mercury as we speak that will pick up where MESSENGER left off. In 2018, Europe and Japan launched Bepi Colombo, named after the engineer who designed Mariner 10's flight path. After years of gravity assists and flybys around Earth and Venus, Bepi Colombo is now on its way to enter Mercury's orbit later this year in November 2026. And it aims to answer many of the questions MESSENGER left behind, including the result of its own destruction. After its job was done, NASA decided to crash land the probe on Mercury's surface, essentially creating a fresh crater in a known location. And Bepi Colombo will analyze the size and color of the crash site to determine the rate of aging on Mercury's surface. Goes to show that a little teamwork goes a long way. But did you know that although Mercury is the closest planet to the sun, it's not actually the hottest? That title belongs to its neighbor, Venus, and the reason why is deadly.